And units is what we're looking at in this video with speed. So it's split into 5 parts. We're first going to start off by looking at examples like this, where we're looking at simple conversions with matching units, then looking at conversions with different times and distance units, where we need to convert that before we get the answer. Then we're looking at different units with speed, and then looking at more problem-solving questions, and finally then looking at an exam question to wrap up with. So the way my videos work, I want to do the example on the left, which is I do, you are then going to press pause and have a quick example on the right, which is you do. So here we've been told a cyclist travels 450 meters in 30 seconds, work out his average speed. So we know the formula for speed, that is speed is distance over time. So that then becomes 450, divide that by 30, and we get an answer in meters per second as 15 meters per second. Now hopefully you press pause and I'll look at the example on the right. So we've been asked to work out the distance this time. So we know that speed is distance over time. I can rearrange this to speed times time. And the units are fine, so that will just be speed, which is 50 kilometers per hour, times the hours, and that is going to be 150 kilometers is the final answer there. So here's some practice questions, press pause and have a go. Here are the answers, mark your work. Now moving on, here we have different units, so we need to do a bit of unit conversion before we get our answer. So what you'll notice here is that the answer is expected in meters per second. Now that's fine with the distance, but the time is in minutes here, so we need to convert that to seconds. So we have the average speed. Speed is distance over time. So the distance, like I said, is fine because the answer is in meters. However, the time is not fine because the time's in minutes, but the answer's in seconds. So how do you go from minutes to seconds? Well, 1 minute is 60 seconds. So we know to go from minutes to seconds, you just times it by 60. So that'll be 6, 12, 18, 180 seconds. So now that we've got all the conversions done, we can just substitute that into a formula. So that then becomes distance over time. And that gives us 1200, divide that by 180, and we get our answer as 6.67 meters per second if I round that there. So again, hopefully you press pause and I've got the example on the right. So here it wants the answer for the distance in meters. So if you rearrange the speed equation, we get distance is speed times time. Now that's fine. So the speed is given as 72 kilometers per hour, and the time is given as 25 minutes. So there's 2 bits that are different here, well 3 bits. Firstly, wants the answer in meters, but we've been given the speed in kilometers, so we need to convert that. Secondly, we've been given the time in minutes here, and then the speeds in hours here. So there's 2 conversions required. So the first conversion I'll do is I'll convert the kilometers to meters. So that's now just times this by 1,000. Okay, so that's what I've done there. Now the reason I've done that is because it wants the answer in meters. So that's that done. Now the other problem is before I substitute speed and time into here, they need to be a consistent unit. This is in hours, this is in minutes. So we need to convert either this to minutes or this to hours. I'm going to convert this to hours. So I know that 1 hour has 60 minutes. So if I go down to 1 minute, so I know that 1 minute has 1 over 60 hours. So we're just going to times that by 1 over 60, we'll just divide it by 60 essentially. And we get the answer as, we can just leave it as a fraction, 5 over 12 hours. So to go from minutes to hours, you just divide by 60. And I'll leave my answer as a fraction because otherwise I'll turn into a horrible decimal. So then I can use the formula. So 72,000 times 5 over 12. And that gives me an answer of 30,000 meters. Okay, so the important thing worth noting here is that we had to convert the kilometers to meters because that's what the question wanted it in. But then the speed was in hours and the time was in minutes. So we also had to convert that. All units need to be consistent. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. Now moving on. Now so far we looked at conversion of distance and a little bit around sort of time. But we've not looked at speed conversions, and this is where people often get caught out. So what happens is students see something like this and they say, well, actually 1 hour is 60 minutes. So they're like, well, actually to go from 12 hours to minutes, you just times it by 60. And that is correct. And then you just do 12 times 60, which gives you 720 minutes. Okay, so if you just do green tick, that is correct. Now what happens is, people see something like this and they're like, well, we've got 12 kilometers per hour. I just want to convert that to kilometers per. In fact, let's just change that for the sake of argument here to minutes. I want to convert that to kilometers per minute, and people think, well, actually, surely to go from hours to minutes, you just times it by 60. And that's not right. Okay, you are not timesing by 60 here. Now, the reason for that is because this is a unit of speed. So if I was to write this speed down, so 12 kilometers per hour can be written like this. Okay, so if I want to now convert the hours to minutes, I then do, well, I have to times this by 60. So that then becomes 12 kilometers over 60 minutes. So the actual answer here becomes 12 divided by 60, which is 0.2 kilometers per minute. Okay, so what we've actually ended up doing is dividing by 60 and not multiplying. And this is important. And I do recommend that whenever you see speed and you have to convert it to another unit of speed with different time or distance, you write it out as a fraction, because remember, speed is just distance over time. So whenever you see speed, you see 12 kilometers per hour, just write that down. And now what's the question asking you? To convert this to seconds? That's fine. Then convert this and then just divide it like a fraction. So here's some practice questions we'll have a go at together. So here I've been asked to convert 55 kilometers per hour, so every 1 hour, to meters per second. So the top part's fairly straightforward. So if I convert the kilometers to meters, that'll just be 55,000 meters. Okay, so that's that done. Now the bottom part, how do you go from hours to seconds? Well, 1 hour has 60 minutes and 60 minutes has 60 seconds. So that just means 1 hour has 3,600 seconds. So I'm just going to replace that or multiply that by 3,600 seconds. And then my answer, now I can just do 55,000, divide that by 3,600. And my answer becomes 15.28 meters per second. Okay, it's important that we write it as a fraction. Otherwise, you'll end up multiplying instead of dividing or dividing instead of multiplying. Now, looking at this next one, I've got 15 meters per second, and I've been asked to convert it to meters per hour. So the top part is fine. The bottom part is saying convert 1 second to hours. So I know that 1 hour is 3,600 seconds, but here I've been given 1 second. So 1 second, I'm dividing each side by 3,600. So that then looks like this. Okay, so I'm going to then multiply this by 1 over 3,600, or you can just say divide by 1,300, and then that just becomes 1 over 3,600 at the bottom here. And then if I type that into my calculator, I just get 1 divided by 3,600. With that on top, that becomes 54,000 meters per hour. Okay, so the important bit to note here is to use the fraction. So hopefully you've pressed pause and had a go at these here. So here we've been asked to convert 60 kilometers per hour to meters per second. So let's convert the top bit to meters. So that's nice and easy, that's done. Let's convert the hours to seconds. So we know to go from 1 hour to seconds, you just times it by 3,600. So that becomes 3,600. And now I'm just going to divide that. So 60,000 divided that by 3,600. And that gives me an answer of 16.67 meters per second. And looking down here, we have 12 meters per second. We're converting that to meters per hour, so the top part is fine. Now to go from seconds to hours, you are just going to divide that by 3,600. So 1 divide that by 3,600, that just becomes 1 over 3,600. And then finally, if I type all of that into my calculator, I end up with an answer of 43,200 meters per hour. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. Now moving on, we're looking at questions with different units of speed. So here we've been given the distance in kilometers, and we've been given the speed in meters per second, and we've been asked to find the answer in minutes. So there's a few things that are different here. I can see there's minutes here, but then there's seconds there. And I can see there's kilometers here, but then there's meters here. So a few things will need adjusting to get the answer here. So we can just write it out simply. So we have the speed as 20 meters per second. We have the distance as 2.4 kilometers. And then they want us to find the time in minutes. So we don't know what the time is, but we know that to find the time, the formula we use is speed is equal to distance over time. So the actual formula just becomes distance over speed. So now we have a choice to make in terms of the distance. Do we want to work in kilometers or meters? And that's completely up to us. So what I'm going to do is I'm just going to work in meters. So I'll convert this. I'm just going to times that by 1,000. And that is now in meters. So that's the distance unit sorted, because that's in meters, that's in meters. We're happy with that. The only thing we're not happy with is that's in seconds and that's in minutes. So we can convert that. So we can remember with speed, you want to write it as a fraction. So that's 20 meters every 1 second. Now, how do you go from this to minutes? Or how do you go from seconds to minutes? So you know that 1 minute has 60 seconds, but here we have 1 second. So 1 second has 1 over 60 minutes because we divide each side by 60. So then it's just a case of, well, you just times this by 1 over 60. So that becomes 1 over 60. And that then becomes 20. Divide that by 1 over 60, which becomes 1,200 meters per minute. And now we just use a formula. So we know time is distance over speed. Everything is consistent. We have 2,400 meters. Divide that by 1,200 meters per minute, which means the answer is going to come out in minutes, which is 2 minutes. That is my final answer. Okay, so what's worth bearing in mind here is that there was quite a few conversions involved to get the final answer. And again, hopefully you've pressed pause and had a go at this. So the first thing you should have noticed is that's in kilometers, that's in meters. So something needs to change here. The answer's in minutes, but the speed here is given in seconds. So again, similar to before, we have a speed, which is 3 meters per second. Fine. We have a distance, which is 0.9 kilometers. Again, I would just change this here personally. There's a few ways you can do this. Now, distance-wise, we're talking meters and meters. That's what we're happy with that. The only thing we're not happy with is that's in seconds, that's in minutes. So let's fix that. So that's 3 meters per second. And that just becomes 3 meters over 1 over 60. And that's now in minutes. So if I just type that into my calculator, that'll just be that. That gives me 180 meters per minute. And now I just use the formula for time, which is distance, 900 meters divided by 180. That should say meters per minute. Meters per minute. So 900, divide that by 180, and I get 5 minutes. Okay, what's important is that the units must be consistent. Time must be in the same unit, so that's either seconds or minutes, not different, and the distance should be the same as well. So here's some practice questions. Press pause and have a go. Here are the answers. Mark your work. Now moving on, we're looking at slightly more problem-solving questions. So we've got 2 people that have ran a 200-meter race, so we know the distance is the same. Tom finishes the race in 28 seconds. Ali runs an average speed of 25 kilometers per hour. So how do we know who wins the race? We know they've both run the same distance, so that doesn't help. So either we need to work out the time it took Ali to run the race, because we can then compare that to the time it took Tom, or we need to find the speed that Tom ran at. So it's completely up to us here what we find. So we either find the time it took Ali, or so here we either find the time and compare that, or here we find the speed and compare that. I'm going to go with Tom, and I'm going to look to find his speed, because if I know what the speed of Tom is, I can then compare that to the speed of Ali and figure out who was quicker. So we need the speed, which is distance over time. Okay, and the units need to be the same. So the distance given in the question they've ran is 200 meters. I'll convert that to kilometers. So that's fine. And with the time, Tom took 28 seconds. I just need to convert that to hours. So I know that 1 hour is 3,600 seconds. And I know that 1 second is 1 over 3,600 because we're dividing each side by that. So converting these seconds to hours, we just divide this by 28, divide that by 3,600, and that becomes, I'll just leave that as a fraction, which is 7 over 900 hours. Right, and then finally, we just substitute that into a formula. So speed is going to be 0.2 kilometers. Divide that by 7 over 900. So that's 0.2 divided by that, and you get an answer of 25.71 kilometers per hour. Now you just compare this, to Ali's speed, and you can see Tom was quicker. So who wins the race? That would be Tom was quicker, and we can just write 25.71 kilometers per hour. And like I said, you could have also done this question by figuring out how long it took Ali in seconds and compare that. So hopefully you've pressed pause and had got the example on the right. Again, you can pick whether you work out the time here or whether you work out the speed here. It's completely up to you. You can go down either route. So here, what we'll do is for runner A, the units are quite nice here actually. So the units are very nice actually. So for runner B, we'll just do runner B and we'll find his speed. That seems nice and straightforward because speed is distance over time. Now what's good here is all the units are consistent. The distances are in meters and the speed is in seconds. So I can just use this formula straight away. So the distance is 400, the speed is 55. Sorry, the time is 55 for runner B. So I just do 400, divide that by 55, and I get the answer of 7.27 meters per second. Now I can immediately compare that, and I can see runner B was slower. So who finishes the race first? That would be A. So here's some practice questions. Press pause and have a go. Remember, make the units consistent. So the distances and the distance and the speed should be the same, and the time should be the same as well. So here's the answers. Now moving on, we're looking at an exam question. Now feel free to press pause at this point and give this a go yourself. So we've been asked to find out Amy's average speed. So we know that speed is distance over time, and we know that Amy wants it in hours. So 45 minutes. So if you just divide that by 60 to get it in hours, that would be 0.75 hours. And the way I did that is that 1 hour is 60 minutes. And then I know that 1 minute, to get to 1 minute, you divide this by 60. So that just 1 over 60 hours. So we know she took 0.75 hours, but we don't know the distance. So what we need to find in this question is the distance. What's the total distance? And it's the same distance that Jessica runs. So Jessica, the distance is speed times time. So that'll be 6 times. So if I convert this to hours, because we want to work in hours really, because that's what the question wants. So that becomes 0.25 hours. Well, that will become an awkward fraction. So that'll be 40 divided by 60, which is 2/3 as an hour. So that'll be distance is 9 times 2 over 3. So if I do 6 times 0.35, that becomes 1.5 miles. And then 9 times 2 over 3 becomes 6 miles. And then if I add them both together, that's 7.5 miles. So that's 7.5 miles. Divide that by 0.75, and that gives me a speed of 10 miles per hour. And if you would like some more practice on this, I've got a full worksheet link down below. And if you found this video useful, I've got loads of other content like this. Do check it out.